Next, we're going to learn some basics about alkane nomenclature. And we'll kind of build up the rules, starting with some of the easier ones and working our way up to naming harder molecules. All alkanes actually have the same general formula, which is in the upper right corner. C sub n H2n plus 2, where n is just some number. So that would mean if n was equal to 1, the simplest alkane that we could have would be C1, and then H2 times 1 plus 2, which is 4. So our simplest alkane would be CH4, and that is called methane, with just one carbon. So our alkanes, if you remember, are saturated hydrocarbons. They are all going to contain sigma bonds, no pi bonds, since they only have single bonds within their chemical structures. So here's a couple examples of some common alkanes. 3-carbon alkane. Now remember, here's your carbons at the end and at the corners of the line bond structure. It's called propane. Butane has 4 carbons in it, and then pentane has 5 carbons in it. And so if we were using our general formula for our alkanes, propane would be C3, and then H, you would do 3 times 2, which is 6, and then plus 2, which is 8. And so you should be able to easily figure out what the molecular formula is for any of these just simple alkanes. And you could also, if you needed to, practice placing the carbons and hydrogens on the line bond structure. So at the end you would have CH3. Remember, there's 3 hydrogens bonded to the carbon at the end because carbon forms 4 bonds. And then there would be 2 hydrogens coming off of this carbon right there. So that's where your 8 hydrogens are. Your formula for butane would be C4H10, and your formula for pentane would be C5H12. So you can kind of see that general formula there, how it's building up. Notice the suffix, which is the ending of alkanes. They all end in ane. So all alkanes will have that same suffix that you see there. So later when we learn different classes of molecules that we'll name, the suffix is often what changes. And a lot of the rules that you learn just in this first nomenclature chapter will apply all year long. So before we start actually naming and practicing, let's look at what kind of all the rules are, and we'll talk about them separately, but we'll get a general idea then of everything that we're going to have to consider. So you can see that there's a prefix we're going to have to learn how to name, and those are the substituents that are on your chain, if there are any. A parent, which will be the parent or the longest chain. And then you have a suffix, which changes. And in this case, we said we're naming alkanes, so our suffix is ane for alkane. So here are some steps we're going to follow. First, find the parent chain, which is the longest consecutive carbon chain. You can have kinks, you can have turns, you can have bends. The goal is to find that longest chain first, and sometimes it's very straightforward, sometimes it takes a little practice. Then we identify and we name any substituents coming off the chain. Sometimes they are side groups, sometimes they are halogens, sometimes they are complex groups coming off. We want to number the parent chain, and we're going to have to learn the appropriate way to number it. And we are going to assign a number to each substituent when we number it possible. When we number the parent chain in the correct way, I do mean. So we're going to give the first substituent the lowest number possible. And then we're going to list the numbered substituents before the parent in the name in alphabetical order. So we place them in ABC order, regardless of what number they got when we actually numbered the chain. And sometimes there are prefixes that the substituents have that we ignore when we place them alphabetically, such as the word tert, which has a hyphen after it. You don't look at T for that. That's just an example. We'll talk about that in a little bit. But the prefix iso, you do go by the letter I. So that's just an example of some of the kinks and things we have to kind of teach you first. But this is kind of the gist. We're going to go through some of these steps one at a time and build your knowledge of nomenclature up. So first, let's talk about finding the longest chain, or in other words, the parent chain. The parent chain will determine how we name the compound. So when you're looking at this molecule, this line bond structure, it kind of just looks like, a bunch of branches and lines, but you want to count and you want to try to find the longest continuous carbon chain. So, maybe you started right here and you went 1, 2, 3, 4, 5, 6, 7, 8. So is 8 carbons our longest parent chain? Or, then you checked and you went 1, 2, 3, 4, 5, 6, 7, 8, 9. So there I was able to find a 9 carbon long parent chain that I wrote in purple, which is going to be our longest one in this example. Now don't worry about what side I started numbering 1 versus numbering 9 from. We'll learn that in a minute, but right now we're just trying to find the longest continuous chain, and you can have kinks and turns and bends. So sometimes you just have to try writing out the numbers and finding it. So in that case, that would be our parent carbon chain with 9 carbon atoms. And those 9 carbon atoms will have a prefix and a suffix that we use to name them. So looking at this table here, you can see that depending upon the number of carbon atoms in the parent chain, there is a parent name that corresponds to that number of carbons. And you need to memorize numbers 1 through 12. You're going to be using them all year. Sometimes you'll even use beyond that, but for quizzes or exams, I just want you to know 1 through 12. It doesn't mean for homework or other things that there's not other ones that you could see. So there is another version of this chart on Blackboard that I have up. If you want to check that out, it might be a little bit easier to print off and have it for your notes while you're learning them. But for example, if your longest carbon chain had 1 carbon, then the name would be meth. If your longest parent chain had 2 carbons, then the name would be eth. 3, prop. 4 is bute. 5 is pent, 6 is hex, 7 is hept, 8 is oct, 9 is non, 10 is dec, 11 is undec, and 12 is dodec. So on our previous slide, we found the longest parent chain and we found 9 carbons in there. So looking at that, adding our suffix ane, that would be called nonane as the parent. Okay, so now coming back and looking at that same parent chain that we identified that had 9 continuous carbon atoms, so that was our longest continuous chain, we would say that the parent is nonane, and we can break that up into 2 parts. The non prefix tells us that there's 9 carbons, and the ane, the ane, tells us that it's an alkane. So we haven't fully named this molecule yet. This is just the first part, is finding that parent chain. If there's more than one possible way to number a parent chain, like let's say there's 2 ways and you end up with the same longest continuous carbon chain, we want to choose the one that has more substituents attached to it, which are side groups. So for example, maybe we start numbering the molecule on the left 1, 2, 3, 4, 5, 6, 7. So we found 7 carbons in our longest continuous chain. But what about if we numbered it like this? 1, 2, 3, 4, 5, 6, 7. So both ways we identified 7 carbons in the longest chain. The molecule on the left, though, has 1 methyl group, so one side chain, 1 ethyl group, and another ethyl group. So we'll learn the names of the groups in a moment, but there's 3 side groups, which are called substituents, versus the one that's on the right. There's an ethyl group coming off right here, and then this is called an isopropyl group. So there's only 2 side groups. So that would mean that we would choose our numbering pattern to match the one on the left and not the one on the right, because we want to maximize the number of simple substituents
rather than complex substituents and having less of them. Once you learn the names of the common parent chains, it should also be fairly easy to learn the names of the substituents because they basically are the same thing, only the ending is changed. So, for example, one carbon in a substituent group or a side group coming off of the parent chain is called methyl. Remember, one carbon had the prefix meth, and then we added the suffix ane. Well, all of our substituents end in YL. That's how we know it's a side group. So once you know that meth part of it for one, you just add the YL. This would be a methyl group right here. So remember, what's not written? We're not writing out that CH3 that's coming off. So that is a methyl group. If there's two carbons in the substituent chain, that's called an ethyl group. So right here, highlighted in green at the top, that would be a carbon here, that's a CH2 group, and then at the end is a CH3 group. So a CH2CH3, that's referred to as an ethyl group. 3 carbons in a side chain is called a propyl group. So here we have 1, 2, 3. So that in the lower left we would call propyl. So each of these side groups has a name, but they end in YL because they're not the parent. They're not the longest continuous carbon chain. So once you know the names of your regular alkane groups, you should be able to name the alkyl groups as well. So 1 through 10, we have methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, and decyl. For you to have a 10 carbon side chain, you would need a parent chain with 11 carbons or more. There are also some common substituents that just have common names that are used more than the IUPAC names, so you just have to memorize them and be familiar with them. For example, if this is our parent chain in the lower right corner here, that group attached there is called an isopropyl group. Now, isopropyl is a common name that you would just have to learn, but the rules name, the IUPAC rules, is 1-methyl ethyl. So we would need to name it as a complex substituent, which we haven't even covered that just yet. So an isopropyl group has 3 carbons like a propyl. So propyl, we said it had 3 carbons coming off, but it's an isomer of that propyl, which is where the name isopropyl comes from. So here we have a carbon, and a carbon. So if we were to draw it out longhand, it would look like this. CH3, CH3, this would be our parent chain, some point of attachment, and then we would also have another hydrogen coming off of that central carbon that's unshown. So isopropyl is a group that you're going to want to know when you see that branched alkyl group that has 3 carbons on it. Different arrangements of butyl also have some common names, and there are 3 of them. So just normal butyl, or sometimes referred to as N-butyl. Remember, butyl or but meant 4. So there's 4 carbons in that side chain if it's attached to a parent. And the different isomers over here of our butyl have a few different names. So we have sec-butyl, which notice the parent is attached to the secondary carbon. So 1, 2, 3, 4. That's how I remember that. It is attached at carbon number 2 when it's a sec-butyl group. So the real name for that would be 1-methylpropyl. Notice that the sec is written italicized and it's hyphened with the butyl. That means that when we come and use ABC order later to put these in alphabetical order, when it's like that, you use B as your alphabetizing letter, not sec. Versus the next one, as we go to the right, which is isobutyl. Isobutyl has this arrangement of the 4 carbons, still 4 carbons. It kind of looks like an isopropyl, but there's that little extra kink in it. So 1, 2, 3, 4 carbons there, and then all their associated hydrogens. That's really called 2-methylpropyl. But that does not have a hyphen, and it doesn't have iso italicized. So when we go by ABC order, that one goes by I. So if there's no hyphen, it will just go by the letter that it starts with. So sec-butyl will go by B, Isobutyl will go by I. And then another arrangement of 4 carbons is called the tert-butyl group. So we got 1, 2, 3, 4. And it kind of looks like a trident, if that helps you remember, and it starts with a T. So tert-butyl, the tert is also italicized and hyphenated, so that will go by B for butyl when we look at it in alphabetical order. So I suggest for these common substituents that you make yourself some note cards so that when you see them, you can identify them and be able to name these branches coming off of your main chain. All right, so let's try putting together a full name using everything we've talked about so far, including parent chains and substituents. The next thing we got to add to that is how you number your parent chain. Like what direction do you start in? If you only have one substituent present, it's fairly easy. You give that substituent the lowest number possible. So when deciding, am I going to number 1, 2, 3, 4, 5, 6, 7. That would put my substituent at number 6. 7 is definitely my longest chain, but instead I want a number starting from the left. 1, 2, 3, 4, 5, 6, 7. So I would follow the red numbers instead of the purple numbering because that put my substituent right here at position number 2, which is a lower number than 6. So now that we've numbered our parent chain, we know that our parent chain is 7 carbons long, so that stands for hept. And then the suffix is going to be ane because we have an alkane. So heptane is our parent. And then we want to list our substituents. We only have one group in this case, and it has 1 carbon on it. So that's a CH3 group that's unwritten at the end there. So 1 carbon alkyl group is called a methyl group. I suggest in the beginning you list your substituents underneath your parent. So this would be listed as 2-methyl. We separate the letters with numbers and hyphens in between them. So you specifically want to write the position as 2 because that's where it lives on that parent chain. And then you put that hyphen in between the number and the letter. So assembling the whole name now, this would be called 2-methyl. And then there's actually technically no space in between here, but sometimes I leave a little one so you can read it better, but it's just heptane at the end. So that would be the full name for that molecule. We only had one substituent to worry about. But notice all the parts that are included. The prefix, which included our substituents, in this case just the 2-methyl, the parent, which was hept, and the suffix, which for an alkane is ane. Okay, so next, when you have multiple substituents present, we want to number the parent chain to give the first substituent that pops up the lowest number possible. So when we're going to start numbering between these two, we could start on the left and go 1, 2, 3, 4, 5, 6, 7. Or if we were to have numbered on the right, we would have went 1, 2, 3, 4, 5, 6, 7. So on the right-hand side, our side groups are at 3 and at 6, versus on the left, 2 and 5. So notice our first substituent came up at position number 2 when we numbered starting from the left versus starting from the right, it popped up at number 3. So that means that our numbering on the right is actually incorrect and our numbering on the left picture is correct. So now we have our longest parent chain numbered, and we're going to list out our substituents as well. So we have 7 carbons. This is heptane, and we have a 2-methyl because that's a single carbon group there. We also have a 5-methyl. So now when you have two substituents that are the same, such as both of those being methyl groups, we can actually combine them. And we can use Greek prefixes out front in order to indicate how many of the same group there are. So you might remember your Greek prefixes from general chemistry when you were naming compounds that were made up of 2 or more nonmetals. So we had mono, di, tri, stuff like that. So when we put together two methyl groups, they'll become a dimethyl group. So how we're going to write this name then, the full complete name is going to be 2, and we separate numbers with commas, so 2 comma 5, and then numbers from letters with hyphens, so we put a hyphen there. And instead of just saying regular methyl, we're going to write dimethyl. And then we need to add our suffix, which is heptane. And all of this seems like very, restrictive, and we have very specific things like hyphens and commas and spaces or not spaces. But these are all the rules that you really need to follow if you want to get full credit for properly naming organic molecules according to a very strict set of rules. So 2 comma 5 hyphen dimethyl heptane. And when we end up learning alphabetical order, I'll just point this out right now, we don't use those Greek prefixes such as di, tri, tetra for ABC. We ignore those for ABC order. So that would end up going by M if we had to alphabetize. And we'll look at that in a little bit. Okay, next, so if you have multiple substituents and you have some ties you have to break, then you have to give the next substituent the lowest number possible. So basically, the thing to remember is you're always trying to give your side groups the lowest number possible. So if we start numbering on the left on our first molecule, we'd have 1, 2, 3, 4, 5, 6, 7. And if we start numbering from the right, we'd have 1, 2, 3, 4, 5, 6, 7. Now, notice on both of these molecules, there is a tie. We have a methyl group at 2, we have a methyl group at 6. We have a methyl group at 2, we have a methyl group at 6. So the first substituent came up at 2 either way. So then we want to look at all the other substituents. If we numbered with the purple side on the left, we have a substituent at 5, versus if we numbered it from the right in the red, we had one at 3. So our numbering on the right would be our correct numbering because it gave our substituents the lowest number possible, versus our purple on the left would be incorrect. So on the right we have 2, 3, 6, versus on the left we have 2, 5, 6. So that second substituent was at 5 versus being at 3. All right, so now that we have our correct numbering and our longest parent chain, our parent chain is still going to be heptane, hept for 7 carbons, ane for an alkane. And in this case, we have 3 methyl groups. So putting this together, we would write 2, comma 3, comma 6. So those are the locations. They're called locants. That's where those substituents live. And we're going to put a Greek prefix out front to indicate that there's 3 of them. So tri would be the prefix for 3. And the name of these groups is methyl, so trimethyl. And then that all is our prefix part of our name. And then we just have to add heptane to the end. So our full IUPAC name following the rules is 2, comma 3, comma 6, hyphen, trimethylheptane. Next, if you come across a scenario where there's no tiebreaker based upon assigning the lowest number, then we now use ABC order as the tiebreaker. So we give the lowest alphabetical order the priority for numbering. Something we'll look at in a little bit, the halogens have some common names. So Cl, a chlorine on an organic molecule, is called a chloro group. Br, or bromine, that halogen is called a bromo group. So numbering these, we can start on the left-hand side. We can go 1, 2, 3, 4, 5 carbons. We don't want to keep numbering because the next atom in the chain, that's not a carbon, that's a bromo. Or starting, that was a chloro there. This was our first carbon at position 1. Second carbon, third, fourth, and fifth. So be careful of that. Or on the right, we can go 1, 2, 3, 4, 5. So notice your substituents are at positions 1 and 5, whether you number from the left or from the right. So there is no tiebreaker in that case. That's when you would move on now and say, okay, well, now I need to look at alphabetical order. So chloro would go from C and bromo would go from B. So that means that giving our bromo group the lowest number possible, because B is lower alphabetically than C, is going to be correct. So that would mean our numbering on the right is the correct numbering, and our numbering on the left is the incorrect numbering, where chloro was given number 1. So now we have a 5-carbon long parent chain, which you might look at your chart until you got these memorized, but 5 carbons is pent. And then we add our suffix, which is ane. So that's our parent, pentane. And at position number 1, then a hyphen after, we have what's called a bromo group. And then at position number 5, we put a hyphen and we have what's called a chloro group. So those are our only 2 substituents in this molecule. And then when we assemble this together, we assemble it alphabetically. So who gets listed first in the prefix of the name? Well, bromo got the lower numbering, but 1 bromo also gets listed first. C got the higher numbering because it was higher alphabetically, and it gets listed second. So our full name then is 1 hyphen bromo, and then we write another hyphen to separate a number and a letter, and then we write 5 hyphen chloro. Now we don't need any hyphens or commas because we're just going to write another letter. We add our parent, pentane. So we don't have any multiple groups. That's why we didn't need to use any commas, because we didn't have to combine any same substituents in this example. So we have 1 hyphen bromo, hyphen 5, hyphen chloro, pentane. Okay, so let's do a review and do a practice of kind of putting everything that we've talked about so far together. So we want to number our chain, find our continuous longest carbon chain. And sometimes you just have to write down some numbers and count and erase until you figure out what that chain is going to be. So I'm going to start down here. We have 1, 2, 3, 4, 5, 6, 7, 8. And if I start numbering it that way, it looks like octane is going to be my longest chain. If you pause and you kind of count around, you might see that you get 8 carbons going a couple different ways. Some ways you'll end up with just 7 carbons. If I start numbering this way, my first substituent is at position 2. If I was to start numbering the other way, 1, 2, 3, that's incorrect. My first substituent would be at position 3 then. So we don't want to do that. So we're going to stick with our numbering that we have. And then your next thing is you want to list out everything you have. So oct is going to be what you use for 8. And then octane, because we have an alkane. And then at position number 2, we have a methyl group, 1 carbon. At position number 3, this is one of those common ones that you have to memorize. It's got 3 carbons, but it's not a straight chain attached. It's an isomer. That's called 3 hyphen isopropyl. At position 4, we have a methyl group. In position 6, we have a methyl group. So now that we've had our list, we would essentially end up listing everything in alphabetical order. So what do they go by for their ABC order? Well, something like methyl would go by the letter M. Something like isopropyl would go by the letter I. Next, since we had 3 methyl groups in our molecule, we're going to be able to combine those methyl groups and use the Greek prefix out front in order to put them all together in the name. So at position 3, that was our only different one. That was our isopropyl. But at positions 2, 4, and 6, we got 3 methyl groups. So how we'll end up combining those is writing 2, 4, 6, hyphen, there's 3 of them, so that's tri, and then methyl. And when you put that in your name, your full name, you're still going to go by M for listing everything in alphabetical order. So putting our whole name together now, we're going to have 3 hyphen isopropyl hyphen 2 comma 4 comma 6 hyphen trimethyl. And then lastly, the parent, which was octane. We had 8 carbons and we have our alkane. So that's our complete systematic name for that molecule. It's a lot to take in the beginning, but as you practice all these rules and you just, do more practice problems, it will become second nature. And once you learn a lot of the basics, they carry over for the whole entire class between organic 1 and organic 2. You should pretty much be able to name any organic molecule once you know a lot of the basics. So let's just review the things that we did to put together the entire complete name. First, we found the longest continuous chain, which is our parent chain. We learned some different rules to assign numbers. And then once we numbered it correctly, we gave a number to every side group, which is called a substituent. Then if we had multiple substituents that were the same, we combined them using a Greek prefix. But those Greek prefixes, whether it's di, tri, tetra, penta, those are not included in ABC order. That part doesn't count, the di, tri, tetra, penta. It would be the methyl, ethyl, propyl, pentyl. That part would be what we look at. Then the substituents are arranged in alphabetical order in front of the parent name. So just like we said, prefixes are not used. So things like tert-butyl, the B was our ABC order. Sec-butyl, the B was our ABC order. Iso, that's not hyphenated, so that goes by I. We saw that numbers and letters are always separated by a dash, and numbers, such as when you're combining substituents, those are separated by commas. So those are just some of the basics to keep in mind when you're doing your practice problems. Okay, let's do an example. Name the following molecule. So first let's start numbering. It looks like if we start in the upper right corner here, we're going to have 1, 2, 3. That gives us our first side groups at position number 3. And then 4, 5, 6, 7, 8. Versus if I started down where the 8 was, I wouldn't have even had a side group at number 3. So putting them at the lowest number possible, maximizing the amount of side groups that we have, and finding the longest continuous carbon chain. So we got octane as our parent. And then at position number 3, we have right there, we have a 3-methyl. Also, we got another group coming off of number 3. That's an ethyl group, so 3-ethyl. Notice that one has 2 carbons, 1, 2, whereas the methyl group just has 1 carbon. And you got to remember there's hydrogens coming off of this entire alkane, but we don't see any of those either. And then we have one more group here at position number 4, and this is one of our common name ones. That's going to be 4-isopropyl. So when we arrange these in order, we're going to go by M, E, and I. Now, we used to combine, multiple methyls, or you could combine multiple ethyls, but you can't combine methyl and ethyl. Those are different substituents. Just because they're at position 3, there's nothing we can combine there. So putting the whole name together now, we're going to start and list ethyl first because that's the lowest alphabetically. So 3-ethyl, and then we're going to have a hyphen to separate our next number. Next in our listing comes I for ABC order, so 4-isopropyl. Next comes M-3-methyl. And then I'm out of room, so I'm going to write below. We add our octane, O-C-T-A-N-E. So the full name of this molecule is 3-ethyl, 4-isopropyl, 3-methyl octane. We mentioned two of the common names for alkyl halides so far, but here's the rest of them. So any alkane or any carbon group really at all, generically, no matter what it looks like, is sometimes referred to as an R group. So let's say we are focusing on the halogen, the chloro group right there, that you could see abbreviated as this, Cl attached to R, where R is this whole mess of carbon and hydrogens right there. If what we're not really worried about is that part of it, it's often just called an R group. So that's an abbreviation you'll see a lot throughout organic textbooks if you're ever wondering what R is. So when you have some hydrogen carbon chain and you have a bromine group attached, that's called a bromo, and that goes by the letter B for alphabetical. When you have a chlorine attached, that's called a chloro. A fluorine group attached is a fluoro. Notice the spelling, F-L-U-O-R-O. When you have an R group attached to an iodine, that's called an iodo group. So having a proper spelling, it's a lot like anatomy and physiology. It's very, very important to have the correct spelling as well as the correct hyphens and commas and everything else that we talked about in order for your names to be systematically correct. Okay, so a couple more practice problems here. Starting with the molecule on the left, I'm going to number my longest chain. I'm going to start numbering from the left, 1, 2, 3, 4, 5, because that puts my two chloro groups at position number 2, giving that substituent the lowest number possible. So I have 5 carbons in my longest chain. That is pentane. And then I have a 2 chloro. That's one of my groups. I have another 2 chloro. And at position number 3, I have a methyl group. So in this case, we can actually combine our chloro groups, not because they're at the same number necessarily, but they both do happen to be at position number 2, but just because we have 2 of them, we can combine them. So how we would write that for combining is 2, comma 2, hyphen, there's 2, so we say dichloro. And putting this together alphabetically, we're going to go by C for chloro and M for methyl. So our full name here is going to be 2, comma 2, dichloro, hyphen, 3 methyl, and then our parent, which is pentane. Okay, looking at the molecule on the right. So we can kind of see that the longest chain runs left to right. I'm going to want to start numbering it on the right though, because that will put my first substituent group appearing at number 2, versus if I started numbering on the left, it wouldn't come until number 3. So I don't even have to move on to any other tiebreaker than that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our parent chain has 10 carbons. That is called decane. And then now we want to list out what we have for our substituents. At 2, we have a methyl group. At position number 5, looking along here, that is an isopropyl group. At position number 6, we have a bromo group. And then lastly, at position number 8, we have another methyl group. So we are definitely going to combine our 2-methyl and our 8-methyl. That will become 2, comma 8 hyphen dimethyl. Those two. And that's what we'll use in our name. So we're going to go off of I for isopropyl, B for bromo, and M for dimethyl. And then our parent is decane. So putting the whole name together now, we're going to start with our bromo because that's lowest alphabetical. We're going to have 6 bromo, hyphen. Next is I for isopropyl, so 5 hyphen isopropyl. and then hyphen next again, and then M would be last. So 2,8 hyphen dimethyl. And then there's really no space after this, but I'm out of room, so then decane. Next, we want to practice going backwards the other way. So if you are given a name, can you draw the molecule? And actually, this can be a little bit easier because you have a lot less to decide upon. You don't have to provide the numbers. The numbers are already provided to you. So in our first one, we have 6-chloro, 5-ethyl, 2,3-dimethyl undecane. You want to remember that undecane is 11 carbons in the longest parent chain. So we'll start with that. Let's draw a chain that has 11 carbons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I'm sorry, my tablet pen is a little bit broken, so it's a little bit sloppy, but that's why it turned out wavy. Yours will be a lot nice and neater and straighter than mine is. But that is 11 carbons. So double check after what you draw and make sure that you actually have 11 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's very easy to draw it and actually have the wrong number of carbons down because the first point where you put your pen or your pencil down on the paper is actually your first carbon there. So that's why it's actually good to go back through and number it. Now at position number 6, we're going to have a chloro group. So we'll add our chloro substituent there. At 5, we have an ethyl. And so you can draw that as 2 carbons coming off of there. Also, if that's our parent chain and that's an ethyl group coming off, you'll also see it abbreviated like this. Some people will just write ET as an abbreviation for ethyl. Or you could see something like this. If this was our parent chain and a methyl group was coming off, even though this doesn't really save any time, people will put ME for methyl coming off of there. But for the ethyl, notice how you had 2 branches showing when you showed out the longhand way, carbon 1, carbon 2. But when you just write ET, that means the exact same thing. I think it's good to practice in the beginning actually drawing them out to help you memorize them. Next, we have 2,3-dimethyl. So at position 2, we're going to draw a methyl. And at position 3, we're going to draw a methyl. And that's it. That's our whole molecule there. So it's a little bit easier drawing them from the name. You just got to take your time and then double check it at the end. Let's look at the next one. 2,4-dibromo, 2,4-dichloro, 5-propyl decane. So the ending here, start with that decane. That means we have 10 carbons in our longest chain. So let's draw a chain that's 10 carbons long. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at position number 2 and 4, we got some stuff going on. So this is position 2, 3, 4. We'd have one there. So at number 2, we're going to have a bromo group. At position number 4, we're going to have a bromo group. And we're also going to have a chloro group at 2 and a chloro group at 4. Notice how I drew that spot when I have 2 groups coming off of it, how I kind of angled them away from each other. Remember when we talked about drawing double bonds and triple bonds, how you're trying to show the appropriate geometry? You never draw a group coming down like that in between your chain. They go up from a point. So that's because you're trying to show that tetrahedral geometry, that 109.5-degree bond angle is the best you can on paper in 2D. So if you have a point pointed down, your groups would come down. If you have a point pointed up, your groups would come up, never the other direction. And we have one more group to add at position 5. So at number 5 right here, we're going to have a propyl group. Propyl is 3 carbons long. So we're going to have 1, 2, 3. And you still draw those with kinks and bends coming off appropriately. The other abbreviation, we talked about a few over here, 1, 2, 3. For propyl that you'll see is just someone writing PR. So all of these quick little abbreviations are things that you'll see that people use to kind of make it easier when writing really big, messy molecules. So that's going to be our structure for the second one. One of the last things that we're going to look at when naming alkanes is what you do when you have a complex substituent that doesn't have a common name. So it's not a common propyl or isopropyl, it's not a tert butyl, it's not an ethyl. So we don't have a name for it. And that's when you have these complex branches that we've got to have some rules for. So first you still find your longest continuous parent chain, such as this guy. But then that side branch, it might not have a common name. And you want to work within that side branch separately now. Number the longest carbon chain within that complex branch, and you're going to start with the carbon that's directly attached to the main carbon. So what that means is if this is the main carbon that's directly there, this is going to be the first carbon that's attached to it. So we're looking for the longest chain within here. So 1, 2, 3, 4 there. So there's 4 carbons within that side branch. And then next we're going to name that substituent, and we'll talk about how we add that to the full name in a minute. We give any of the side groups a number as well within that substituent. So we have to differentiate essentially between our numbering of our parent chain and the numbering of our side branch. So for our parent chain, originally we might go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And whether we had started on the left or the right, our substituent, our complex branch would have popped up at number 6. So what we do for the numbers is we add these little dashes at the top, these little apostrophes that are called primes, in order to differentiate them from the main parent chain numbering. So this is called 1 prime. This is called 2 prime, 3 prime, 4 prime. So it's just a little apostrophe written after the number. And that's how we know that those numbers are on a sub branch and not on the main branch. So when you come across this, and we want to name a molecule that has a subbranch without a common name, first follow the rules that we talked about so far. Find your longest continuous chain. We got 11 carbons in this case, so we're going to have un decane. Un dec is the prefix for 11 that you need to know. And then we talked about how we're going to number our substituents of our side branch using that prime method. So starting with the point of attachment at number 6, we got 1 prime, 2 prime, 3 prime, 4 prime. So what do we call something that has 4 carbons in it and it's a side group? Well, 4 carbons is a butyl. But in this case, we have another little group coming off of our side butyl. It's at position number 2. So at 2 prime, we have a methyl. So 2 prime methyl. And all of this is located at position number 6. So how we would write this out is we would say 6, and then we would put a parenthesis, and then we would say 2 prime methyl, and then we're going to list how many carbons are in the subbranch. So that's the substituent on the subbranch is the 2 prime methyl, but our subbranch has 4 carbons in it, so it's a butyl group, and then we're going to close that parenthesis. So that subbranch at number 6 is listed in parentheses. And notice I didn't write butane, I wrote butyl, because I'm not going to end it in ane because it's not the parent. It still is just a substituent. So make sure that you're ending your substituents in YL. In this case, we don't have anything else to look at alphabetically for listing it, but if we were going to put something else with it on the molecule and list it in alphabetical order, you would look at the name of your whole subbranch and you would go by the first letter. In this example, the first letter happens to be an M for methyl, so that's what it would go by for ABC order is M. But putting this all together then, the full name is going to be 6 parenthesis 2 prime hyphen methyl butyl. So we have a methyl butyl group. close parenthesis, and then un decane. So let's work the other way around now. Draw the molecule 1, 2, 6, 7 tetrabromo, 4, 1, 2 dichloroethyl nonane. So we got nonane, which tells us there's going to be 9 carbons in the longest chain. And notice how you have a number with parentheses within it? That kind of tells you, hey, you got a sub-branch that you're going to have to draw, where you got that number right in front of that parenthesis. So we're going to start off with drawing 9 carbons in our longest chain. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we'll start with the easy low-hanging fruit, the tetrabromo first. So 1, 2, 3, 4, 5, 6, 7, 8, 9. At position number 1, coming off of 1, we're going to draw a line, and then we're going to draw a bromo group. Now, it looks like I added a carbon because it looks like I made the chain longer, but I didn't. That bond is to bromo there. It just looks like that because I went off on an angle there. So that's still position number 1. 2, we got another bromo group. 6, bromo, and then 7, bromo. So that takes care of our tetrabromo. Tetra is that Greek prefix for 4. So those were all combined. And now at position number 4, we have a 1, 2 dichloroethyl. So how you kind of break this up is the ethyl ending of the subbranch tells me that there's 2 carbons in that subbranch. And at position 1 and 2, there's chloro groups on that subbranch. So coming off of 4, there's going to be 1, 2. That's my 2 carbon chain there. So this would be called 1 prime, 1 prime, and 2 prime. And then we will put our chloro groups on there. So this would be 1 prime chloro, so Cl coming off of there. And then at position 2, we have another chloro coming off. And actually, I see a typo in this question. This should say 1 prime right there and 2 prime right there in the actual name. So add those in there to your notes that those primes are missing. So we would have for 1 prime, comma 2 prime dichloroethyl. That's another way to kind of like indicate to you that you have a subbranch going on is when you see those primes. So this would be our overall molecule that we would draw for this structure.